All right, in this question, we're being asked to determine the slope of each line segment. So if we look at A, well, we could make this into a triangle, just so we can more clearly see the rise and the run. And then we can kind of just, in this case, count the blocks. And the reason we can count the squares is because, you see on my X, they're going up by one every time, and my Y, they're going up by one every time. So we can just count those this time. So if I count the bottom here, it goes over 6, and it looks like it goes up, goes 5 up to there, and then another 4, it goes up 9. Okay, well, straightforward enough. Our slope is really just rise over run. So our slope in this case would be, well, the rise was 9, and the run was 6. So then that would simplify to, you can divide 9 by 3 and 6 by 3. So 9 divided by 3 is 3. 6 divided by 3 is 2. So there you go. Our slope, m, is equal to 3 over 2. All right, so now I just want to show you that we could have found that a different way. Actually, a few different ways. What if I did this? What if I went over 2, up 3? Do you see how I landed like nicely back on the line again? That would work too. So I could have just looked for a place where it crosses the graph, like in a nice, like directly over where a square crosses there. And then just say, okay, well, it goes up 3 over 2. And then that would have been it. I could have just said 3 over 2. I could have also chose this point here. You can see it's like 3 over 2 in that section. Or this section. Or I could have went, what about this? I could have went over 4. And then I could have went up 6. Right? So if I went up 6 over 4, well, 6 over 4, well, that would just also simplify to 3 over 2. So it doesn't matter where we pick our points, as long as it's from some point on the graph, the ratio would always be the same, right? So it will always simplify down to the same number. Okay, hopefully that makes sense. So let's look at B. So now this time, let's do the same thing. I can make a triangle, and I can make the triangle actually anywhere I want. Maybe you're seeing it. I could probably pick right here, right? And then just go down 1 over 3. That would work, right? Or if you really wanted to, we could go down and do the whole thing as a triangle, right? So now it goes down 3 over, and then what's that go over? 4, 5, 6, 7, 8, 9. Okay, so our slope is at negative 3 over 9. And I guess I should have mentioned this. I went negative 3 because it's like we were starting on the left side, right? It's like we were starting here, and then we went down 3. So think of that as like, so minus 3, right? The negative is accounting for us going down. And it also makes sense just by looking at it, right? Because if you have like this last graph, like when we were going from the bottom and then going up the hill, it's like we were climbing a hill going this direction. Well, when we have a negative slope looks like you're just like sliding down a hill, right? That's what a negative slope looks like. And the reason because of it is because we're going this down 3 part. Okay, moving on. So after that, so now we've got the slope is equal to, and I can divide 3 and 9 by 3. So I'm going to go negative 3 divided by 3 is negative 1. 9 divided by 3 is 3. So we have a slope of negative 1 over 3. All right, so now let's look at C. Determine the slope of the line that passes through. Now it just has 2 points that the line's passing through. We could make a graph and actually plot these points and then, count it. But we actually have a formula for this. So it's m is equal to y2 minus y1 over x2 minus x1. All right, so now what are those? Well, y2, like later, I'll label these first. So if we look at this point here, this E1, well, this is an x value and this is a y value. So let's call this x1, and I'm going to call this one y1. And then for point number 2, right, my other point, I'm going to call this x2, and then this y2. So those are the x's and y's that are going to go into our equation. So now let's just plug everything in. So y2. All right, so y2 was 6. y1 And make sure you just put minus either way, right? No matter what y1 is, because we've got minus, and then y1's negative, right? So I'm going to put that in brackets. So like minus negative 5. And you might remember what happens when you go minus a negative. I'll deal with that in the next step, but think about that. What's that going to turn into? All right, so now I'm looking at my x's. So x2 minus x1. All right, so x2 was 8. X1 was 4, so minus 4. That one's pretty straightforward. Now, this one here, 6 minus negative 5. If you remember that if you go minus a negative, that's actually the same as adding. I always kind of remember this here because it almost looks like an addition sign when it's in brackets like this, because it can almost turn into one. I don't know. Maybe you can see it, maybe you can't. But either way, 6 plus 5 is 11. And then 8 minus 4 is 4. So we have a slope of 11 over 4. Okay, so now before we move on, I just want to draw your attention over to what I've drawn over here. So I actually plotted these points roughly on a Cartesian plane just so we can kind of see what's happening here. That blue line's supposed to be straight, but just use your imagination. So now, why did that work, right? So why did that work? Well, if this is our point here, right? Oh, shoot. If this was our point here, and we had, 8 here was, this was x2 and this was y2, right? And this was x1 and this was y1, just from the points here, right, is all I did. Then if we found the slope of this guy, is all we're doing, then the rise, right, the rise part of this, if you wanted to figure out what that was without actually counting the blocks like we did above, well, then what we would do is we'd take this value, this 6, and we would subtract the bottom value, this one, right? And that would give us this. That would give us like the actual rise. Well, that's exactly what we did here, isn't it? So this top part, this really is just the rise. And that's how we're finding it. And then the bottom part, like the run, well, if I wanted to figure out the distance, like across the bottom here, well, then what I would do is I'd go 8 minus 4, right? That would give me the distance there. And that's what we did here. So this part is really just the run.